Good morning, everyone. Today I will share a lesson plan that you may use it for your lesson observation for secondary 3 chemistry topic acid and bases. So I'm going to use a simulation tool to illustrate the difference between strength and concentration of acid. This is an important concept that students need to understand in one of the important learning objectives for this topic, acid and bases. I'm going to use the active learning process to guide you through the steps in running this lesson. The active learning process include, number one, activate learning. How do we engage our students, get our student interest in the topic? Use of ICT is very helpful to get the students interested in the topic. Number two, promote thinking and discussion. We do not want the lesson just to be fun. We want students to learn important learning outcomes and grasp the concept better with the use of ICT. So the exercise or the activity worksheet is provided to promote thinking and discussion. Students can work in pairs to discuss the work and share ideas within themselves and between each other in the pair before they start to present their answer. Number three, facilitate demonstration of learning. So after the students completed the worksheet, they will present their answer, or they can upload their answers into Google Drive for students to view each other work and for the teacher to view the student work and to provide some feedback. Number four, monitoring and provide feedback. The teacher and the student can do their own feedback. So the teacher can choose selected work and discuss and ask thinking questions to facilitate learning, to reinforce the learning in the classroom. Okay, so this is an exercise worksheet aligned with the simulation tool that I'm going to show you later. The link can be provided later. It will be in my YouTube channel with the title or the comment there. All right, so you can access the website, it's free of charge, and design your own worksheet to use it for your lesson observation or use it to help your student better understand the concept in acid strength and concentration. Okay, now, so the objective of the lesson is to describe the difference between strong and weak acid in terms of its ability to dissociate in water and generate a particulate representation of strong and weak acid. This can be applied to bases as well. All right, so this is the design of the worksheet. There are two parts, part A and part B. So part A basically, right, requires students to use the animation that I'm going to show later to differentiate between strong and weak acid in terms of pH, color of pH indicator, electrical conductivity, the types of particles in solution, and comparing the concentration of particles in solution based on the graph. So they can also see the difference between the concentration of acid versus the concentration of the ions. They're actually not the same, but some students assume them to be the same, which can be captured through this activity. Okay? So there are some questions or guiding questions to help students think further, like how do they distinguish a solution of a strong acid from a solution of a weak acid based on the particles, based on what they have observed from the animation, assuming that both have the same concentration, which has a higher concentration of hydronium ions, or in mainstream school, it was taught to be H+. All right. In part B, right, which I'm going to show you later as well, is the second part of the animation called My Solution. So they are going to compare between acids of different concentration and equal strength to compare their pH, electrical conductivity, and types of particles in solution. And then after completing the activity, filling up the blanks, they have to answer questions like, giving a qualitative comparison of amount of particles in a weak acid of a different concentration. And the same for strong acid. And to determine the two factors that affect the concentration of hydrogen or hydrogen ions that resulted from the dissociation of a specific acid. And they also have to think, why is it important to ensure that the concentration of the two acids are the same if you compare their strength? All right. The exercise can also be extended to include base to reinforce learning. So now I'm going to show you the animation to see how we can relate the worksheet to the animation. All right. The link will be given later. So this is the animation tool. You have the introduction as well as the my solution. So if you go to introduction, so this is how the animation looks like. So this is the pH meter. All right. There are few solutions to select here. So you can actually extend it to base because it also have base and they have molecules, solvent, graph. So a lot of questions actually can be asked. Okay, so it depends on the learning outcomes. I'm going to focus on acid and base, or you want to focus on more variables. Okay, so this is a water. So if you put the pH down at room temperature, pH is 7. Okay, of course, you can tell the students that at their level, they only need to know that H plus and not hydrogen ion yet. But of course, we all know that hydrogen ion was the ion that was present upon dissociation of water. All right. They also can understand that, oh, water is actually not just a molecule. Some water molecules do get dissociated, but very few. So we assume that water is neutral. Water doesn't form ions, which is wrong. Water does form ions, just that the quantity of the ions are not a lot. And because the concentration of the hydrogen ion or the hydrogen ion and the hydroxide ion is the same, so it turns out to be neutral. Okay, let's say you have a strong acid. Let's put this up again. Then they will need to put this in. Oh, pH 2. All right, so they also can see from the diagram that there is a lot of hydrogen ion formed. And there is no HA and H2O there. Yeah. HA, which is a strong acid, completely dissociated. So there's no HA there. Okay, so I take out this. So the degree of dissociation is related to the pH. So they can see from there. Weak acid, you can see that, oh, the pH is larger, 4.50, but there are undissociated molecules, HA. So weak acid doesn't completely dissociate. It partially dissociates to form a lower concentration of hydrogen ions and the anion. Okay, so they can see directly the difference between strong and weak acid based on the particles representation. Because it's very difficult to tell them verbally. It's clearer if we show them an animation or a video on what exactly is strong acid and weak acid. It's helping them to visualize the particles interactions between a strong and weak acid. And then we can repeat that for strong base, okay, as well as weak base. Okay, now, so if I move on to strong acid, if you want the student to see solvent, which is water, it can be shown there. Okay, the view can be changed to graph to compare the concentration of the ions and water. Okay, so for weak acid, so they can either view it in terms of particle arrangement or view it in terms of graph. This is very helpful because it allows them to analyze better. And many questions nowadays like to include graph and table. So understanding the graph is very helpful for them to solve questions. and improve their data handling skills. So they should be able to relate the molecules interaction with the graphical representation. Okay. Then you can have various tools, not just a pH meter. You could have this one, universal indicator paper. Strong acid, red. Weak acid, yellow. Strong base, okay, should be violet lah, okay. Then weak base should be even lighter color. Then you can have the electrical conductivity measurements for weak base. Strong base, even brighter. Weak acid, dimmer. Strong acid, brighter. Cool, right? All right, then they can restart it if they want to analyze other variables. Okay, so this is for part A. For part B, I mean, many of us already know the existence of this very useful website, which include chemistry and physics animations. But the question is, how are we going to set questions, how to set activity questions to help us use the simulation to our advantage? That is the key point. The tools are always there, but how to use it is something that we need to learn. Okay, so this is comparing in terms of the value. So you can actually, okay, this is very important because it talks about the difference between strength and concentration. So for example, okay, I'm just focusing on acid lah. So this is the concentration of the acid, 0.01 mole per liter or mole per dm cube. I have a weak acid, but if I change it to a strong acid, okay, you can see that, okay, the pH decreases as I increase the strength of the acid. Okay, so they can actually like have an activity worksheet which I showed just now. If you have two acids of the same concentration but different strength, how will the pH be different? And maybe ask them to think why. Why is it so? So let's say you have a weak acid. So a weak acid, you could have a pH of 6. Okay, maybe I choose something that's very concentrated. A very concentrated acid, maximum that the software can drag is until 1 mole per dm cube or per liter, 5. If I have a strong acid with a very low concentration, then it will be 0.001 mole per dm cube. The pH is 3, but increasing the concentration will lower the pH. So you can see that concentration affects the pH. Strength also will affect the pH. So there are two factors that affect the pH, strength and concentration. And of course, basicity, which is not emphasized here. So you may have additional questions to ask about basicity, comparing hydrochloric acid with sulfuric acid. All right, that's something that the software can include lah. So you can actually use this simple simulation to illustrate the difference between strength and concentration. And based on what you see in the worksheet just now, right, how the concentration must be the same if you want to compare acid of different strength, one strong, one weak acid. Okay, because concentration affects the strength. So if you do not allow that concentration to be the same or to be a controlled variable, the strong and the weak acid may have different concentration, but their pH will be very close to each other. Then it's not an accurate measurement of their pH. I mean, you cannot really say that, okay, this acid is stronger than this, or this acid is a strong acid, the other is a weak acid, because their concentration to be compared is not the same. Okay? Okay, so I hope, let me go back to the worksheets to end off. So something like this. Of course, this can be modified further. Yeah, so what I do here is that you can actually make a comparison between, let's say, a weak acid of 1 mole per liter versus a strong acid. Yeah, then you have to ask students this question. Do you think it's really very fair to compare their pH like that? Of course, you can actually go on to compare their conductivity and types of particles in solution to describe. Maybe types of particle solution can tell them to write maybe are there more molecules or more ions, etc. Okay, I hope this sharing is very useful. Many of you already been using this and could have even better worksheets than this. But I'm just here to share what can be done further. Okay, so that's it. Thank you.